we're going to look at just vertex in standard form, look at some questions that we've seen in the past, and then we'll take a little break, and then we will do factored form, and then you'll have a question. Oh, my phrase is bad today. That's cool. That's all right. No worries. No worries. All right. So first off, vertex form. So you remember the vertex form is written in this way, and obviously, hopefully, we remember some of the like what all those variables mean. So, for example, right, we know A, right, is like, you know, the vertical stretch or compression, right? But also for a parabola, right, if A is bigger than 0, so positive, then we know the parabola opens up. If A is less than 0, then we know it opens down, okay? Now, one kind of new thing that we kind of emphasize is that if a parabola opens up, so remember, if it opens like this, right, if this is what the parabola looks like, it opens up, then it has a minimum. So we, you know, this one will be a min, and if a parabola opens down like this, then it has a maximum or a max, okay? And then obviously for vertex form, the cool thing about it was that it gave us the vertex. And the coordinate of the vertex is h and k. All right. So pretty basic stuff that we did talk about when we looked at the functions unit, or we kind of graphed a little bit and we used the parabola, the quadratic to help us. All right. So what we're going to do now is just do a couple of examples about us finding equations of quadratics. All right. So here we want to determine the vertex form of the equation for the function shown here. So I got this nice little function here. It's a parabola, and I want to find the vertex form equation. So again, remember, if I have vertex form, right, it's y equals ax minus h squared plus k, right? So again, when you look at the graph here, well, clearly I have this coordinate here. I can figure out the coordinates because the graph is nicely labeled, but it's also put here, right? So and we know this here is a vertex. Oops, I almost spelled vertex with a K. That would look cool, but not grammatically correct. Okay. So that means in terms of like what we know here, like, so, you know, okay, we know. Well, we know the vertex, right, which is some, like the coordinate hk, which is here 1 and 5, okay? So that means in my equation here, x, now notice if the h is positive, right, in there, then it has to be a minus. Okay, so minus 1 squared, and then plus 5 because the k is positive, all right? So all we're doing is kind of taking the information from a graph and process of elimination, figuring out the only unknown, which is the a value. So if you check it out, right, like this a value, unfortunately, we can't plug in directly because no one coordinate on the graph will give me the a value, okay? So again, when you look at this, right, we say, well, okay, what is left? Oops. Okay. Well, if I look, I have an x, we have a y, and we have an a. Now the a is unknown, right? That's the, and hopefully, or maybe this triggers some sort of memory from grade 10 where you did some questions where when you need to find the equation of a quadratic, generally you're given every single piece of information except for the a value, and that you have to get through algebra. Okay, so I don't know what a is, which means I must know an x and a y. And obviously, if you look here on the picture, I'm given 2 points, right? Here is a point, and here is a point. And that is good because then I'm going to pick one of these points. And, if I pick this one, right, this has an x and a y value, right? So if I pick this point, the x is -1, the y value is 2. So now we're going to plug this into our equation here. And then I have everything I need to then solve for a, all right? So we will plug these into our equation, all right? So I'm going to have 2 equals a right? My x is -1. So -1 take away 1 plus 5. Okay. And then now what we're going to do here is just solve for the a value. All right. So now we just do some, elementary algebra, nothing too crazy. All right. So 2 equals a. Well, -1 take away 1 is -2 squared plus 5. Now this plus 5, I'm going to bring across. So I'm going to have 2 take away 5 equals, well, what's -2 squared? -2 squared is 4. This is going to be 4a. 2 take away 5 is -3 equals 4a. And then the last thing is divide both sides by 4. So a equals -3 over 4. So my equation is going to be y equals -3 over 4 x minus 1 squared plus 5. Okay. So generally speaking, for all the questions involving vertex form, right, where you have to determine an equation of a quadratic, generally you're going to be given, right? Like for example, in this question, I'm given the vertex and I'm given 2 points, but you could have picked. I mean, shoot, like on this graph, like this point is nice, this point is nice, this one is nice, this one is nice. Like there's a bunch of points you could have picked, but you only need to pick one. And if you picked, say, this point here, 3, 2, guess what? You're going to get the same a value. Okay. So hopefully everyone feels good about that. So let's move on. So here are just some kind of general reminders about key points of a parabola. So generally, we look at a few kind of important components, right? So first, the y-intercept. So that is the point where the x value is 0. All right. The x-intercepts are the points where the y value is 0. Okay. Again, none of this should be new. The x-intercepts are also called generally we call these zeros. So you may have heard them also be called the roots. All right. So when we refer to x-intercepts, generally I'll call them the zeros, or maybe the roots. Okay. And the vertex is either the maximum or minimum, which I alluded to on the previous slide, right? If this opens up, right, this is a minimum. This is the minimum value, right? If a parabola opens down, then it has a peak, and this is the maximum, okay? So again, we're just going to, again, if we remember these ideas, then it helps us in solving some questions. And again, nothing really drastically new here. Okay. So again, determine the key points, vertex zeros, y-intercept, and say the domain and range of the function. So here we have a function that is in vertex form, okay? And we just want to figure out the key points. So let's just go through them and then determine all of those ones, and then we'll see what happens, okay? So I want to find the, right, so we got to find the vertex, the zeros, y-intercept. So those are the key points, and then we'll look at domain and range. Okay, so obviously the easiest one to find first is the vertex, because this is in vertex form, right? Okay, so in general, remember vertex is HK, and then it's -1 and -12, okay? So that one is pretty simple, okay? So check mark there. Next, let's find the zeros, okay? So remember, for the zeros, what does that mean? Well, the zeros are just the x-intercepts, okay? And when we look for x-intercepts, the y value has to equal 0, okay? So that means in my equation here, let me just scroll this down, right? If I look, I have f of x equals 1/2 x plus 1 squared minus 12, okay? So remember, if the y value equals 0, well, that's the same here, right? Like this just means like f of x equals 0, because remember, y and f of x are the same thing. So I make this equal to 0. And then now what do I do? Well, if I let you think about that for a few seconds, there's only one thing I can do, okay? There's only one unknown here. That's x, and I'm solving for x. And if you think of it logically, like no one should be surprised that this is happening, because that's what I'm doing. I'm looking for the x-intercepts, which means that I'm going to be solving for where the y values are equal to 0, okay? So now solving this should hopefully no big deal, right? I'm going to move the -12 across. So it's going to become +12 equals 1/2 x plus 1 squared. Okay, I'm going to multiply both sides by 2, then those will cancel. So then I have 24 equals x plus 1 squared. Now we're going to talk about how we introduce the new ideas. So now we're putting in a radical, because watch, how do I, the whole goal is I want to get at this x. This x is trapped inside this bracket. Okay, the spell that has trapped this x in the bracket is a bracket to the power of 2. How do I undo that spell? Well, I just square root it. So if I square root both sides, okay? So that means on this side, all I have is an x plus 1. And then here, what we just got to remember, when I square root something, right, the answer actually is a plus and a minus. Okay? Right? Because again, technically, if I have like the square root of 4 is plus or minus 2. And this is important because I want to find my zeros, my x-intercepts, and this is telling me that I now have 2. Okay? And then last move is just to move this positive 1 across. So what I'll get -1 plus or minus the square root of 24. Okay? And this is where we differ from grade 10 and we deal with our zeros in grade 11. We're not going to write these as decimals. We're going to leave these, as we said before, right, as exact values. Okay? So that means we're going to keep the radical. So in this situation, what we have to do is we have to see if I can simplify the radical to get a simpler solution. Okay? So again, what do I have here? Well, we have two answers. I have x equals -1 plus the square root of 24. And then I have x equals -1 minus the square root of 24. Okay? Now, we can let's do one and then we'll know the answer for the other one, right? Well, I know I can write 24 as a multiple of a perfect square, 6 times 4. Okay? So that means x is going to equal -1 plus this. What's the square root of 4? That's 2. We get 2 root 6. Okay, and this is my simplified solution. Okay? And that means that this one, if I go down here, x, this one's going to be -1 minus 2 root 6. All right? So these are my two zeros, right? Or roots, or x. Oops, why did I write a q? X-intercepts. Okay? So again, this is where, like, again, it's not, we're not always going to require answers to be in exact form. But again, this is the new thing that we introduce with quadratics, where if I'm looking for a solution to a quadratic, or finding the zeros, I want my answers to be in exact form. I don't want decimals. All right. So that was that, and I believe we have one more. We have to find the y-intercept. So holy crow. Okay. So we did that. Zeros, vertex. So now we need to do the y-intercept. And this one is easy, right? The y-intercept, we just set x equal to 0. So now I'm going to do the same thing. I'm going to write out my equations. What is it again? 1/2. Yeah. Okay. And again, if you like, if you want to change f of x to y, that is totally okay. Right? If you want to write it as y equals 1/2 x plus 1 squared minus 12. Right? We're going to set x equal to 0. So I have a y equals 1/2 0 plus 1 squared minus 2. And then now, I mean, now we just solve for y. And this should be pretty easy. We're going to have 1/2. Well, 0 plus 1 is 1. What's 1 squared? Well, 1 squared is just 1. Okay. So then I have y equals 1/2 minus 12. And then here, well, I can get myself a common denominator, right, which is going to be 2. And then y is going to be 1 minus 24 over 2. So this is going to be negative 23 over 2. Okay, so therefore the y-intercept is going to be 0 and negative 23 over 2. All right. So notice I'm keeping things in their exact forms. So now I believe we have one more thing to kind of look at. And that is just the domain and range, because we found all the key points. So again, here what we're going to do is I'm just going to draw just a little grid here, just to help me get the domain and range. And again, it's not asking me to draw anything, but I mean, you know, we live in a free society. I can draw a graph if I want to. So again, this graph has 2 zeros, right? Now again, it doesn't really matter where I put them, because the zeros don't really affect the domain and range. What affects what I need to determine the range is the vertex. So the vertex, if I go down here, right, it is 0 and negative 23 over 2. So, again, I don't really care where I'm putting this. Right? So here's, oops, sorry, I messed that one up. Oops, put that back. Right, and we have -1. Let me just move this just so it looks nicer, because again, it's just a sketch. We don't really care about like perfect accuracy. So this is -1, and let's just, let's say this is -12, right? So I have the dot here, and I know my parabola is going to go like this, right? And again, this here is my vertex, which we determined was -1 and -12, right? So that means this is a minimum. And when I find my domain and range, again, hopefully by now we know that for a parabola, the domain is x can be any real number. The range is going to be y is any real number, but y is going to be bigger than and equal to -12. Okay? So again, the graphing part, not so much anything new, and nothing that you really need to worry about. The new, or sorry, not the new, but like the algebra we've done here is the same. The steps, you found vertexes before, you found zeros. Now we're just leaving them in exact values. Okay? So hopefully that is okay. Now we're going to talk about standard form. So we're going to do a similar kind of question, but then see how we have to approach it when I'm given an equation in standard form. So again, here's our equation in standard form, the most useless of forms, just because it doesn't really give us much. Okay. Now again, I'll just write this here in small letters, right? Like, so we do know A, right? So like if A is bigger than 0, then opens up, right? So we know that if A is less than 0, then it opens down. But there's really nothing much else. The only thing it clearly gives us, it clearly shows the y intercept, and that is this plus c here. Because remember, what's the y-intercept? I set x equal to 0. So if I wanted to, if I had y equals a times 0 squared plus b times 0 plus c, then what's left? Well, these go away, and I'm just left with y equals c. So in any standard form equation, the last number, right, the last term, the term that has no variable with it, that will be the y-intercept. But again, that doesn't leave us with a lot of critical information to get a much better picture of it, okay? So if you remember, obviously, to find the zeros, we generally need to, right, we factor, okay? Or we can use the quadratic formula. So hopefully we remember that's this formula: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Cool, fun. All right. So again, either or. Next, to find the vertex, we usually do we complete the square, okay, which is just the process of changing standard form to vertex form. Okay. One trick that I can that we can use, if you sub in x equals negative b over 2a into your equation, you will, yeah, sure, always. You'll always get the vertex. And I'll show you some of those examples later on. So again, completing the square is the algebraic way of transforming a standard form equation into a vertex form. So that's very, like if you're, if you find that the manipulation of equations and variables really is fun for you, then that's something that you can practice over and over again, and then something that you are showing in grade 10. If you just want to quickly get a vertex, like the coordinate, then we can just sub in that value, and it saves us a little bit more time. All right. So let's look at an example. Oh, sorry, one more thing that I forgot. So here This is where we talk about something called the discriminant. Okay. Let me just move this down just to. Okay. So again, the discriminant is a part of the quadratic formula that discriminates between or discriminates the different quadratic functions. Now, again, when I say discriminate, I mean that there are three possible solutions for a parabola. Okay, so obviously, if you look at this picture here, right, this parabola has two solutions or two zeros. All right, this parabola here has 1 0, one intercept, and this one has no zeros. Okay, so you probably remember that from grade 10, you had questions that said essentially like, determine how many solutions or how many zeros does the quadratic have, and I don't need to solve the quadratic. You know what I'm saying? I can use the discriminant. So if we do an example, let's say I have f of x equals 1 second. I just want to make sure there was one specific example I want to use, because then we'll use it on the next one. So you have 2x squared minus 10x plus 11, right? We have this problem. It's in standard form. So again, when you look at it, we say, okay, we don't know much about it. Okay, what do I know? Well, I know oh, sorry. Oh God. Let's just do that and then erase. Right, a equals 2. So that means this opens up. So if it opens up, then I know it's a minimum. And we know the y-intercept is 0, 11. Because again, this 11 here is the y-intercept. But say you were asked determine, let's see, the number of solutions, or zeros to f of x. Okay, so notice it's not asking for the zeros or the solution, just the number. Okay, so that's where we essentially will use the discriminant, so b squared minus 4ac. And again, this is from the quadratic formula right here, and I'll highlight the part, right? So the thing, not the root itself, the thing under the root. Right, the discriminant. Okay, so again, what do I need to use? I'm using this formula, right? So like I need to figure out, well, what is A, what is B, and what is C? And then I plug it in and then just have fun. Okay, so A is 2, B is -10, and C is 11. Okay. So I'm just going to write these out right like this. All right. So B is negative 10, and then H2, and then 11. Right. So then this is going to be 100 minus 88, which is 12. Okay. So again, what does this 12 mean? Right. So because B squared minus 4AC, oops, God, that's horrible writing. Right, is 12, so it's bigger than 0. That means there are two solutions. Okay. There are two solutions, right? Two zeros for this quadratic function. I don't know what they are yet, but there are two. All right. So now let's use that information and obviously more information to do a similar question that we did in Vertex form, but in standard form. Okay. And I think this is the last example before we go for a little break. So again, determine the key points, vertex, zeros, y-intercept, and say the domain and range of the function f of x equals 2x squared minus 10x plus 11. So the one we just dealt with. Okay. So we're going to do the same thing that we did in the previous example, but this is now an equation in standard form, which is unfortunately a little more annoying. Okay. It requires more work. Now, again, remember, what's the quickest one to get? Well, we already got, like, I know, like the y-intercept, right? We know is just 0, 11, right? Because, again, this 11, the C value in the general standard form equation is always going to give me the y-intercept. Everything else, unfortunately, though, I need to work for. So, it's going to require a little bit of time. Okay, so we got this done, so that's good. All right, that's the first thing. Now, second thing, let's get our zeros down, okay? So zeros. So again, remember, to find their zeros, we can factor or use quadratic formula. So let us just rewrite the function and then get to it. So 2x squared minus 10x plus 11. So again, however you want to deal with this, you can say, okay, I want to find two numbers that add to negative 10 and multiply to 22. Then you say, well, what are the factors of 22? Well, 1 and 22 and 2 and 11. And there's no combination of numbers here that's going to add to negative 10. So this one is not factorable. Okay. So therefore, we need to use the quadratic formula. Now, again, that may make some students happy. I'm kind of indifferent to the quadratic formula. But again, remember, like you're not memorizing anything in this course. Okay, if you ever have to use it, you literally have the you have your notes available to you. You can figure out the formula. You just got to make sure you know how to use it. Okay, so x negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, again, we already know from the previous question, right? Because we're using the same function. This has two solutions. So already, you know, when we're thinking about this, I know I should get two answers. And we also know what the discriminant is. We found is 12. So I can plug that in. I mean, what we'll do is we'll do the same thing. A, B, C. So A was 2, B was negative 10, C is 11. Okay? So x equals negative, I'll just write this out. Let me plug in everything. So that's negative 10, 2, 11, and then 2. Okay, and again, this was the discriminant from the last question. So we already figured this out, right? B squared minus 4ac, when I plug in the a, b, and c's here, got what was 12. So I'm just going to put that in there, okay? So we're going to get x equals, well, I don't know, sorry. I don't know why I made that squared. So now we're just going to write out, so here the double negative, this just becomes 10 plus or minus the square root of 12 over 4, okay? So now this is going to give me two solutions. And again, remember, this is kind of the new thing that we're going to do. We're going to leave our answers in exact form. So I don't even care about decimals. But what we have to do here is, right, this I need to simplify. Because I know 12 can be written as a multiple of a perfect square. So that's why I'm going to simplify my answer here. So x equals 10 plus or minus. So again, 12 can be written as 4 times 3, 4. And then, I'll just write this way. 10 equals plus or minus. The square root of 4 comes out, right? So that's 2 times the square root of 3 all over 4. And then here, sometimes it may help you to break it up. So I can write this as 10 over 4 plus or minus 2 root 3 over 4. And then hopefully you see that I can simplify, like I can divide this by 2, divide this by 2. Right? So I'm going to get 5 over 2 plus or minus, and then 2 over 4. Well, that's just 1/2. Okay? So this is like my simplest form. So this may help you to see how I can divide it up. All right? So finally, just if we just go this way here, right? So x equals, so I'm going to have like 5 plus or minus the square root of 3 over 2. Right? So that means my zeros are, so I'm going to have 5 plus square root of 3 over 2 and 0, and 5 minus root 3 over 2 and 0. Okay? So again, this is where we change it where this essentially becomes a grade 11 question because I'm leaving my answers in exact form. And again, this may not be something that you will, like in your grade 12 math classes, you may not always have to do that, like leave your answers in exact form, but most of the time, you will be expected to handle questions where you're leaving all your answers in exact form, which means that like I'm not relying on a calculator to tell me what this nasty, irrational solution looks like. All right. So now we got our zeros. So let's just go back all the way up here. Okay, so we got my zeros. I got the y-intercept. What's the next thing? Is the vertex. Cool. So, okay. Sorry, I'm gonna keep scrolling up and down so we give people a headache. Okay, so let's find the vertex. Okay. So again, the vertex, what we can do is we can complete the square, right? Which is long and tedious. Or we can submit, or we can do that trick that I was talking to you about. And here's where I will explain the trick. And again, I put trick in quotations because it's not a trick. It's just like any human can figure this out just by looking at the quadratic formula. So say, for example, again, let's develop the reasoning behind this trick. So here's my quadratic formula, right? X equals negative b plus or minus the square root of b squared minus 4ac over 2a, right? Okay, so if you look, let's go back a couple. Over here, sorry. So if you look at this one, so here, if I look at this, right, my vertex is a 0. You know what I'm saying? So when the discriminant equals 0, then not only does the parabola only have 1, 0, but the 0 is actually the vertex. Now, why is that important? Well, if I go back to the quadratic formula, right? Oops, sorry. Right, so if the discriminant equals 0, right, then we know the vertex is the x-intercept, essentially. So now what happens now again, we like say you're just like a curious kid, you're like, I don't know, like, well, what happens if I plug that into this ugly looking beast over here, right? Well, then you say, okay, well, what happens? I don't know. You're like negative b over 2a, and then I have plus or minus, 0. Well, then what happened? Well, this goes away, right? It's essentially useless. So then I have x equals negative b over 2a. So now if I think about the picture, right? So again, I have some parabola here where I know it only has one solution. So that means, here's an example of one, right? That means at this point here, right, this hk, right, because this is the vertex, then like this formula here, this will give me, this will give me and you the x value of the vertex. All right. So now again, like the whole logic behind it, you don't really necessarily need, like if you just remember this and use it, that's fine. But let's just implement that for this question. So again, if we want to use, so I have x equals negative b over 2a. All right. So I know my a value is 2 and my b value is, I think, negative 10. Let's just make sure that's correct. Yes, okay. So now when I plug that in, right? So negative b, so negative 10, and then 2, right? So this is going to become 10 over 4, which I can reduce to 5 over 2. Okay. So again, so this is the x value of the vertex. So that means my vertex right now is 5 over 2 and unknown. Now, how do I find the y value? Well, let's plug this in to our function right up here. And I'll get the y value. So we're using the little hint in the quadratic formula. And really, it may seem more complicated right now, but the math behind it is way more, it's more simpler, where you don't have to manipulate and change the standard form equation into vertex form. Okay, so now we plug x equals 5 over 2 into f of x equals 2x squared minus 10x plus 11 to get the y value of the vertex. So let's do that. And then most of our heavy lifting for this part is going to be finished.
Sir, I think that the b value is negative 10.
Ooh, you're right. Thanks for catching that one. Let me just erase that. All right. And then now we just, now we just follow the rules of the defined function. So square whatever has to be squared, subtract whatever has to be subtracted. And then hopefully this part is going to be easier. So let's see. This is going to be 25 over 4 minus, now this I can just multiply. So 10 times 5 is going to be 50 over 2 plus 11. And this is going to be 50 over 4 minus 50 over 2 plus 11. Now again, this one I can reduce. This will be 25 over 2 minus, well, 50 divided by 2. That one, obviously, hopefully most of you see that you don't have to keep that one as a fraction, right? So this one's just going to be minus 25 plus 11. And then now here, like, because this is a nice fraction, right? Like I know if I go 25 divided by 2, this isn't irrational. It's a nice decimal. So I will just change it to a decimal and then we'll get our answer. So 12.5 minus 25 plus 11. So we got negative 1.5. Okay. So therefore, my vertex is, my x value was, what was it, 5 over 2? 5 over 2, the y value is negative 1.5. Okay. Now, again, you could have, like if you like completing the square where you have to algebraically change it from a standard form to a vertex form and then get the vertex, you can do that. Just generally, this is a much faster way to do it. Okay. So I have my vertex, I got my zeros. Only last thing we got to do is, if I remember correctly, just state the domain and range. So again, I'm just going to go down here and just draw myself just a little graph just to help me out here, right? And again, what point do I care about? Well, I care about the vertex because, so the vertex is 5 over 2 and negative 1.5. So notice when I'm going to draw the sketch, like I don't care about precision. I just want the general area of where this point is going to be. So like, it's going to be like, say something like this, right? Here's my vertex, which is 5 over 2 and negative 1.5, right? Now we know this opens up, correct? Because we know we have two solutions. Okay, so here's just a general ugly drawing of this. Okay, so when I look at this, well, domain, well, we know that the domain is, for all parabolas, is x can be any real number. The range is going to be determined by the function and its vertex. So this function, y is going to be any real number where y is greater than or equal to negative 1.5. Okay? And that is that. So again, the algebra that we're doing is, essentially stuff from grade 10. The only new thing is leaving answers in exact form when I'm given irrational zeros or ones with radicals. And really, like this, the trick here that I outlined, this is like, you may have seen it in grade 10, you may not have. Some of you may have figured it out, some of you may not have, whatever. But this is something that you can use just to make your life a little bit easier and speed up your efficiency in trying to answer some questions. All right, everybody cool with that? So why don't we go for our break and then we'll work on some questions. All right.